difficulties, so we switched to Google Meet. So welcome back to the competition. Before we begin, everyone please turn on your camera to welcome our esteemed judges for this competition. Without further ado, let's welcome all the judges. May I introduce the judges for today's competition? To start with, Mr. Stephen Teo Chin Chai, Technical Manager of Precision Motion Control. Next, Mr. Vinit Gupta, ex-Regional Sales Manager for Westermo. Followed by Dr. Li Jianyuan, Head of Advanced Manufacturing Training Academy, AMTA. Next, Dr. Charles Fernandez, Technical Lead of DETS Nots Veritas. And lastly, Mr. Bilal Ali Ahmad, Principal Instrument Lead of Cosbert Maritime. The judges will evaluate your presentation and will mark based on the criteria that we have previously sent to all participants for this competition.
May I introduce today's guest of honor who are present with us to give a few words of encouragement to all the participants of Southeast Asia PLC Competition. First, may I invite now Honorable Director, School of Engineering, Republic Polytechnic, Singapore, Mr. Sohlai Singh.
Thank you, MC Adil. Can you all hear me?
Yes, sir, we can hear you.
Thank you very much. Okay, Mr. Bhushan Abiroy, Chairman IMECI Singapore branch. I'm not sure if he's able to join us in this meeting. I hope he's able to join us. Yeah. Dr. Vinesh Tiruchalvan, Deputy Vice Chancellor and Chief Information Officer of Asia Pacific University. Dr. Arun Siralan, IMECI Academic Liaison Officer from Asia Pacific University also. Our esteemed judges, Mr. Stephen Teo, Mr. Vinit Kumar, Dr. Li Jianyuan, Dr. Charles Fernandez, and Mr. Bilal Ahmad, all colleagues, students, very good afternoon. I'm very happy to be able to join all of you this afternoon, and very nice to see all our young engineers organizing and participating in this event. I understand that this IMECI student chapter of Republic Poly and Asia Pacific University are jointly organizing this Southeast Asia Programmable Logic Competition. This is indeed an exciting event as it allows young and talented engineers to compete among themselves and learn from one another. I understand that there are a total of 12 teams today, consisting 45 students from Singapore, Malaysia, and Brunei participating. I'm really happy to see all of you coming together so passionately on a Saturday afternoon to showcase your technical skills. This is the second year, I understand, in a row that RP's IMECI student chapter is involved in organizing this regional competition. We are proud that our young engineers are actively participating and organizing this event. And this is a great opportunity for young engineers from Southeast Asia to network and collaborate. In fact, IMECI's vision, improving the world through engineering, is aligned to RP's tagline, which is to help our students discover their potential, transform themselves, and achieve their goals. We hope that all from this Southeast Asia PLC competition, the contestants will showcase their technical and communication skills, transforming the world through engineering. Before I end, I'd like to thank the IMECI committee for organizing this competition, as well as my colleagues, Alvin and Shambak, who supported the organizing committee and guided our participants. Best of luck to all the contestants, and I wish everyone a great afternoon ahead. Thank you.
Thank you very much, Mr. Sohlai Seng, for your inspiring speech. Next, I would like to invite the chairman, IMECI Singapore branch, Mr. Kogi Oberoi.
Good afternoon. I'm Kogi Oberoi, as Adil Khan said. I have little more to add to what Mr. Singh has just said, but a couple of things I could say. One thing is the competition has matured. You did a good job last year and you built on it. So the second year, the competition is looking more professional. And that's a good development. And it's definitely a good learning point for the people who organized it and set it up. IMECI is more than happy to contribute to the prizes. And that is an incentive, I know, but that's only a part of the whole picture. The people doing the work on the ground to get the teams to come and present, get the participants to take part, are the real helpers. That's where it happens. We can write a check and give it to you much, much easier than find the people to do it. The other thing which I like to add is that this platform of work is a risk-free platform for you all. If you make a mistake, you will learn from it, but it won't cost you anything. It won't cost your employer anything. Because if it was a real life situation where you have to prove a project which is going to be sold or earn money for the company, and you make a mistake there, you learn, but you also probably don't feel too good because you now have actually lost something for yourself or for the company. And this is the point which you should be making to your participants, that it is a positive experience for you all because you will learn, and even if you make a mistake, you will learn and you will have done no damage to anyone. And that's one of the things we do with IMECI. As for example, Sophie is a competition which we invite young people to participate. And that's where what I think one of the biggest benefits is. And till you make some contributions on platforms like this, positive contributions on platforms like this, you'll never learn anything. You can't learn it from a textbook. You can read it, but you can't learn it. You can't feel it. You can't touch it. And this is where the PLC actual competition differs from presentations which are done on slides. It's real life, real situation. So I would add my congratulations to the organizers. They have done a tremendous job, always do, and they will have learned to make it better, or this one or another one better next year. I would also like to thank all the competitors and the team, and I would like to wish them best of luck and have a very enjoyable afternoon. And thank you for giving me the time to talk to you this afternoon. Thank you.
Thank you for your encouraging words, Mr. Kogi Oberoi. I would also like to invite Professor Engineer Technologist Dr. Vinesh Thiruchelvam, Chief Innovation Officer at Asia Pacific University, to say a few words.
Everyone, and thank you for inviting me to be part of this opening of the Southeast Asia PLC competition. And I'm very happy to see some old friends, Kogi, and some of the other colleagues from the other countries like Brunei and Singapore. Uh, this is the second year running, and I always find it a bit nostalgic when it comes to PLC, because when I first started my career, more than 25 years ago, I was playing with PLC, and that PLC thing has not died off. It's still around. I remember I was working in an environment where there were so many PLC brands. There was Omron, GE, Fanuc, Telemechanic, Siemens, and then Siemens, they had S5, S7. I don't know whether they still exist till today. But my toughest challenge was actually learning how to program all the different brands, how to troubleshoot them, how to ensure that there was continuity on the operations for all the machines. So PLC has never died. PLC is here to stay in terms of mechatronics, in terms of manufacturing, in terms of machine control. So this competition has got real value, and IMACI has continued to support it in its second year running. We will continue to support in the coming years as well. I want to wish all the participants the best of luck. May the best talent win the competition. Yeah. So all the best to everyone, and have a good day in the competition. Thank you.
Thank you, Professor Vinesh. Once again, we would like to thank all the guests of honors and judges for their valuable time. Your presence has graced this competition, and I am sure that all the participants are very appreciative of your words. Before we continue to the next segment, please turn on your camera for the photo. I request everyone to turn on their cameras for the photo session. So in 3, 2, 1, smile. 3, 2, 1. Last one. 3, 2, 1. Thank you, everyone.
All right, before we move on to the presentation stage, let me tell you a few rules and regulations. Ensure that your PLC program is turned on and prepare your simulation and slides. Ensure that all the members in your team have their camera turned on. Please state your team's name and name of all the members in the team before starting your presentation. All right. We'll start with the team's presentation next.
Let's start the team presentation. Each team will have 5 minutes for presentation, followed by 5 minutes Q&A. Without further ado, let's invite the first team, Group Without a Name, from Polytechnic Brunei to present.
Team Group Without a Name here from Polytechnic Brunei.
Team Group Without a Name, can you guys present? Group without a name from Brunei. Can you all share your presentation slides?
Hello, hello.
Yes. Can you share your presentation slides?
Okay, can you wait a few minutes? We have got technical issues going on.
Okay.
Okay, thank you.
Okay, so we will proceed to the next team first and later come back to the team at Polytechnic Brunei. So we will have Team Humans from NTU to present their work. Team Humans, you can start your presentation now.
Hello, give us a moment. Hello, Faisal. Need video. Okay, just stop. Okay, hi, everyone. So share the slides. Oh, yeah. Share the slide here. Okay, we are just sharing our screen. Just give us a moment. Oh, you're doing already. Just display the slides. Okay, sorry. 2 more minutes, please. The iMac. Present. Okay, so yeah, we're gonna start. Okay, so good afternoon, judges and fellow friends. We are Team Humans, and in our team there is Imin, Angel, Sam, and Ying Ying. So right now I'm Ying Ying. I'm presenting to you the starting of this presentation. And before we start, we would like to give Republic Poly a shout out. Thank you for organizing this workshop and competition. And also, however, sadly, due to some technical issues, we were not able to go that far to achieve what is required.
Sorry. Can you on your camera, please?
Oh.
When you are presenting. Thank you.
Yeah, I can. Okay, we are technically in the same place. So we're just doing one person is operating the slide. So yeah. Can you see? Okay.
Yes, can.
Okay. Okay, next slide. Yeah, so this is the project brief that I think everyone was given to create a chemical plant with pump mixers and reset buttons. Next. Okay, so this is a diagram of our PLC. Sadly, there were a lot of errors, and we only managed to do this much where we managed to get the pump A and touch a little bit on the mixer as well. Yeah, next slide. This next slide. This is our diagram. Wait, this is, oh no, this is the video. We'll just show you the video. So first we start the whole thing running by supplying. Next, we switch on the pump A to operate it, to switch it on. Then when it switches on, a 10-second timer goes on. We also have the function block there at the ton to set it 10 seconds, and then you will off afterwards. Yeah, so this is where the pump A offs after 10 seconds. We did try to make the mixer also start after 10 seconds. It started, but we couldn't manage to do the offing part. Yeah. But yeah, this is just our first time attempting this whole software. So this is all we have for now. And thank you for your attention. Thank you. Thank you.
All right, thank you, Team Humans from. We'll pass it to the judges for the Q&A session.
Yes.
Now is the time for judges to ask the team any questions or to give their comments.
Hi, Hume. Can you guys hear me?
Yeah.
Steven over here. So I understand that this first time you're using this PLC. Maybe you guys can tell me more interested about the concept. So maybe you can brief me on the flow, what happens next, so that I understand. Because I believe you have done other programmings. So yeah, then we can assess from there.
The picture. Yeah. The picture. Two more slides in front. Yeah. Okay. Well, firstly, okay, what we worked on was based on the workshop last week that they gave us. So we were given a bit of guidance in terms of using the timer, the TON, and the stop and start parts. We kind of tried to figure out the whole logic behind it by we spent a lot of time trying to figure out how to stop the pump after 10 seconds. We did try using TOF, the off time, the timer which offs after 10 seconds, but we had troubles trying to configure it. So in the end, we used TON, and so to stop it, we used the stop A normally off switch, after the 10 seconds. So that's how we managed to stop it. And then we tried to do the mixer the same way, but we took another quite a long time to try to make it start only after the pump A, after 10 seconds. We did try to make it parallel, but then it kind of glitched. It was like flickering, so it wasn't giving us proper results. So we just totally used a new timer for it for the first 10 seconds. And we managed to switch on the mixer after that. And then now we had to like try to figure out how to stop the mixer again, which we didn't. We had like last 10 minutes to try to figure that out. We could have used we were trying to use a similar method, but we were still trying to troubleshoot where we should make this up. To add on, I think overall it's actually quite a good experience. Like we got the whole logical process of whatever we wanted to implement. Just that maybe we didn't have much experience with this software, so it was hard to execute. Like we know what we need. Like we need to stop the timer after 10 seconds for the pump, and then start the mixer, and then time it like 5 seconds. So it's just very hard to execute with this software since we didn't have much experience. I think we got the logic part covered in a sense.
Okay. Thank you.
Thank you. Thank you.
Okay, so moving on to the next team. Thank you very much. Back to team without a name. Are you ready for your presentation? Group without name?
Yes, he is now trying to share his screen.
Okay.
Ba. He is trying to enter the meeting. Away connection issue.
Is there a technical issue on your end?
There is a connection issue. Yeah, inside the meeting. He is inside the waiting room.
He's inside the waiting room.
Still loading. Yeah. Asking to be let in.
Before you start, can you turn on all of your videos, cameras, so that we know we can identify the teammates?
Meron mo sa buwan. Sudah. Photo mo. Ada cara. Orang kita terus. Testing. Okay. Can you hear us?
Can you hear us?
Yes, loud and clear.
Good afternoon. First of all, good afternoon. So we are from Polytechnic Brunei. So this is our PLC design. Yeah, we are representative from one of the team representative from Brunei. So this is our project, PLC project. To be honest, it's nothing much. To be honest, it's nothing much on here. Because this is our first time doing this kind of project, yung programming project. So as you can see, sino start? Ano na mo tuloy? Setters. So here's the push PBs, push button. So it connected to the close. So here's the 10 second for the pump A, and then as it open, it will connect to the input 3.0, and you continue to open for 5 seconds, and then after the 5 seconds, it will close, and automatically the pump B will be open for 8 seconds. And because it connect to the 3.0 thing, and then after 8 seconds, the mixer will be automatically open for 5 seconds, and the thing will be repeat until it reaches the limit sensor. So maybe that is the thing that we do because we haven't enough time, because this is as you know, this is our first time doing this thing, so it is very hard for us to deliver what we are taught to do.
Do you have anything more to add?
That's all from us.
All right, then
Possible
we'll
to
pass on.
run your program? Possible to run your program? Yeah, simulate.
It's not possible. Wait. How come it error? Memorizing. Oh, ada masalah.
There seems to be an error.
Mr. Steven, there seems to be an error on the simulation. So maybe you can continue on with the next question.
Yeah, sure. I think they can continue. No problem.
Is there any question from other judges for this team? Okay, if not, thank you group without a name for that presentation. Next, we're gonna continue next to the next team, which is K9 from RP. K9 from RP, if you're ready, you can start sharing your screen and turn on your camera.
Okay, hello. So, check first, everybody hear me, right?
Yes.
Okay, thank you. So, today, hello everyone, we are Team K9 from RP. So, today I'm Osaki. I'm joined by my two teammates, Jencho and Hanan. So, this is our problem statement. You have two pumps and a mixer with two sensors. And this is our solution. So on the first one, we have the start BP, which is the push button, followed by the two sensor, S1 and S2, because the problem stated if either one is or two is activated, then it will stop the whole thing. So we design this to be in a series. And next one is the tone, which this is used for triggering the pump A in 10 seconds. As you can see, T hashtag 10S. We connected to the NC A switch to start with the pump A. The pump A is we believe is continued down below at 004, which have the CTU to let us reset the pump after 10 seconds. It send the signal. So when the signal from the ton is sent, the A1 switch in theory will be closed and A1 switch will be open, and it will send signal to two directions. One is to the start, which is to operate the mixer in 02 right here. So the other one will be down to ton 1, which is the pump B. So after this after send to start will be about 5 seconds. After that, the mixer will stop, and up 3 more seconds later, the pump B will start also. Then after a while, then after it get resetted, the switch B is closed and B2 is shorted together. So the start progress is start again, which is the mixer, and also the reset signal to let everything looping again. The RES here is short for recess. We have down below here the bottom one is also 5 seconds as with the mixer. So after the mixer is stopped, it will send a restart signal start from the start to before the S1 and S2, so that it will become a single loop again until either one S1 or S2 signal is activated, and it will break the circuit, break the loop. So HMI, this is our solution. We got the start 3 button, the start button to start the loop, the switch 1 and switch 2 to test out the cases when one of the sensor is triggered. And on the right hand side, we also got 5 LED to indicate the operating started. On the top row, we have the 2 pump, the mixer, and also the switch 1 and switch 2. For the video, because we are having some technical issues, so we cannot do the recording in time. So sorry about that. Okay, so this is now our Q&A.
Judges, you can continue to the Q&A section for this team.
So the simulation is not possible, is it?
The situation that you can see here, it just keep on reading online information for quite a long time, but before that it can work, but before the submission I tried to do some last minute fixing, and so now it's having this error, so I cannot fix that yet.
Okay, sure. Just since you guys are studying and studying as a fresh, I can recommend something also here. You can add a comment line for each of the ladder one for the people to read what is the logic behind it. For example, start, stop, all this is okay, but what logic does it performs on each ladder? If you make it as a comment on top, that's how normally. This is a few lines of programs, but if you are going like a few hundreds of ladder logics, it's very difficult to read through and understand the logic. So it is always good to have a comment on top of each of the ladder one. Yeah, keep it up, good. Yeah, thanks.
I have a question.
Yes.
Did you, I know you couldn't run the video, but did you ever get it to work the way you wanted to in your trials?
In the way trial, the sequence of activation is the way that we wanted to do, but so far we're still having the problem with the restarting the pump to get it to an off position so that we can start the loop over again. The problem we have is actually the signal here. We cannot get it to to reset from the start. So the ton here cannot restart itself, and that's the only problem that we're having until now.
What is the total time of the whole one cycle?
I think everything together, then I would say about 23 to 25 seconds.
And you have said you had a problem with starting the mixer.
Mixer, so far we can get it to operation. So far, the CTU here, which you want to use it to reset it, haven't been tested because the problem that I mentioned earlier about the building, connecting online with the software.
How much more time would you need to fix it, do you think?
This one I'm not sure, but if possible, then maybe I guess about 2 hours, maybe, so that we can have go through once more again of everything and to make sure everything is working properly.
Is this fix be by trial and error, or will you apply some fundamental knowledge to say that's where we have made the error, let's fix it? Or will you just keep trying different options and hope one of them work?
I think the way that we would approach it is to go from the basic, from the logic one, to see whether the logic is right or not, and also the way we use the function block. Because so far, then I think there are some point that it doesn't make sense. So I think the first step will be the logic and the purpose of the function that we need to go through again.
Right. I'll make the point why I asked these questions, because working is fine. I mean, that happens in real life. It doesn't work and you need more time. But then to add to Bilal Ali Ahmed's note about adding comments on each logic ladder, you have to also record what you've already tried. Otherwise, you keep trying the same thing again and again and not make progress. So there's that discipline. If you know fundamentally what's wrong, you can work your way through step by step. This is what I should have done. But this is what I did. So fix that. But if you're saying I'm going to try this and don't really know how it's going to come out, then you need to have some sort of discipline in your approach. Otherwise, you'll spend a lot of time probably even doing the same things again and again. And it's this, at least from your problem statement, I got a glimpse of what you're trying to do. So I was able to comment. Thank you very much for that.
Thank you.
Thank you, Mr. Kogi. Next, we will have Team MDIS Task Force from MDIS to present their work. Is MDIS here? Okay, they are not here, so we'll proceed to the next team, which is the Goblin Gang from RP to present their work. Are you here? The Goblin Gang from RP. Is Team Goblin Gang from RP here? Can you all share your screen? Share your presentation slides.
Please give us a moment, yeah. Hi everyone, this is Team Goblin Gang. So the team consists of me, myself, which is Changhua and Sherman. Yeah.
So this is our ladder diagram for our circuit. Can you make it bigger? Sorry. I zoom in a bit. So first right, we like have the start push button, and then after that have a timer for each of it. Cause like the requirement for it is to have certain timing after it closed. So we just put the timer beside the button is required. And after that we use like S2, which is the like the it's like a break like that. So it will like, let's say it reach a certain limit, it will reach the limit, it will um like let it flush through. Yeah. So for the counter that used for the third circuit is like we need to connect first counter, which is like at the second circuit. After that we will put a reset at the below of the counter. After that the queue will be connected to the full tank. Yeah. So once, cause like it can help us to count how many start button we have pressed. Yeah. I think Sean will present like how it the parallel like the backup uh pump for it. Yeah.
So the parallel path for the backup, we just add another initial pump. So when the first sound incoming, it just go through. When it comes to the simulation watch, we have enough to the end our simulation watch. So
Sorry, Sherman, we can't hear anything.
this
I think I'll how to explain. So like we add an extra pump like parallel to the pump A and pump B is because like once it's like, let's say the pump A or pump B has like any problem, like it will go through the backup pump that they put in the parallel. Yeah. I think you can go next slide. So for our circuit, right, it has error. So it's like we are unable to like simulate it, and also like when we face the error, we are unable to solve as like we are not sure which part of the circuit is have the problem. So like we also have tried a few times like redoing the circuit, and like we have like face this problem. Yeah. I think that's all for our presentation.
Yeah, just as a general feedback, it's not a good idea to put timers in series. If you wanted to do these kind of things, it is better to get into the new ladder one. So putting two timers in cascade is sometimes confuse people, and also um, we cannot think of the next sequence. So it's always easy to break down, make it simpler. That would be the best you can try for the next time.
Okay, thank you.
Thank you.
This is Vineet here. Just to because could you not simulate anything while doing the programming, or could you do something while writing the program to simulate, let's say, partially?
Sorry, I can't hear you properly.
Sorry, what I mean to say that while writing the program and downloading to the PLC, so could you do partial simulation, or you could not do the simulation at all?
I can't do the simulation at all.
Ah, okay, you cannot do it. Okay, because one general tip is that when you have an exercise, try to break it down into multiple small exercise, and complete that part. Run it. You see whether it is working or not. Then you go to the second one, and then the third one. Because if you try to do as a whole, you will not know where the problem is. So if you break it down into the small exercises, then you can try to see that, okay, part 1 is done, now I'm going to part 2, then part 3, part 4, like that.
Okay, thank you.
Is there any other comment for this team?
Okay, so next we will have Team Nux and Friends from RP to present their work. Team Nux and Friends from RP, are you here? Adil?
Do we have Team Shinkalian from RP to present their work? Team Shinkalian.
Team Chinkalion is here.
Okay, you may present your work.
Okay, so my name is Ivan, and my team consists of Barry over here, the handsome guy, and also Tongqi, who is Shinkalion herself. And yeah, and here's our presentation. Okay, I'm good. So I'll present my slides first. Wait, sorry, wait. Can you all see my screen?
Yes.
So here is our first slide here, right here. Okay, this is our first slide. And then this is our diagram. The first one was, because our problem statement was this one. So the diagram was, okay, so our diagram was, due to lack of time we couldn't finish, but we were able to finish the first 5 parts. So the first was start PB, stop PB, big side. Give me a sec. Yeah, give us a second.
So sorry, due to a lack of time, we not able to complete the diagram. Able to do the first 5 parts only, which is to press the start push button to turn on PAM A, which will turn on for 10 seconds. Afterwards, pump A will turn off and mixer M1 will turn on for 5 seconds. And then mixer turn on for 5 seconds will turn off and pump B will turn on for 8 seconds. Then after 8 seconds, pump B will turn off and mixer M1 will turn on for 5 seconds again.
So for this one, we just use the TON block to create a diagram to signal the user after 15 seconds or 5 seconds has passed. Also, in the PLC, timers are internal PLC instructions that can be used to delay input and output signals in the PLC program. When the input is activated, the timer starts its operation, keeping track of the time. When this time exceeds the program time, then the timer activates its output. So this is what we show in the PLC diagram in this slide.
Yeah.
And also, and let's see.
Thank you.
Ivan, turn off one of your mics.
Do you have any question for us?
Judges, are there any questions for this team?
For the timer, is there any time inserted? I see you leave it blank.
We tried to add the time, but we were like having some difficulties with that.
Okay. Any HMI?
I don't think so.
Okay.
Are you able to stimulate using step functions, like one by one, at least?
I can show you our simulation.
Hi, you got 2 more minutes left for Q&A. So, yeah. This is a reminder, you have only 2 minutes left.
Our simulation got having some issues.
Problem.
No.
Sorry.
Sorry.
Yeah.
If you all have no questions, then thank you.
Next, we have Team Python Pros from NTU to present their work. Team Python Pros, are you here?
Yeah, sorry, we are here. Yeah. Give me a while. We need to share our slides.
Sure.
Yeah. Hold
How do I share? Yeah, are you all able to see my screen?
Yeah, we are.
Yeah. Yeah. So good afternoon, everyone. Yeah, we are Team Python pros. Yeah, and we will be talking about how we implemented the PLC design given to us today. Yeah. So when we first saw this design, our thought process was that we wanted to put this into a logical process to like implement into a circuit that not all of us are very familiar about. And so firstly we started by thinking about how do we like keep each pump like on for 10 seconds. And after going through a lot of thought, we decided upon a TP block, which allows us to get an output for a certain period of time. Get a true output for a certain period of time when there's a true input from the start of each of our like components for such as the pumps and the mixers. And and we also had difficulties like thinking about how to implement, how to repeat this process continuously throughout the entire mechanism. And and looking at this, it was really intimidating to us at first because it was really beyond like what is fundamental to us. And so this is how our thought process went about that. So in the end, we decided to come with a rough diagram of how we wanted our circuit to look like. And we started thinking about what widgets are needed and plan out a rough idea of circuit. So we did quite a lot of like research and decided upon like some TP blocks and a counter block, a CNT block basically. And so and we felt that there was quite a few online documentation to help us in this project. And so in the end, we just came out with a rough idea of what we learned from the workshop and tried to put it into consolidated idea of what we want. So as you can see here, this is our start P block, which is just a normally open contact that we can use to like start the machine. And this is a positive edge contact block which detects like we thought that we could use it to detect change from like 0 to 1 logic input to like start the mechanism going. And so when the mechanism starts, we decided to put it into a counter block which increases by 1 every time the start button is pressed, as seen here. Which includes a reset button to reset to 0, which is needed, which is tied to our stop button, which we'll be talking about later. And so for the first step, we decided to talk about the first pump, which is pump A, and we decided to use a TP block of a 10-second limit, which will give Boolean value of 1 to the pump A output, which will allow us to pump chemicals for about 10 seconds. And connected to this, you can see this our thought process for how we will implement the backup pump, which is we decided to use a NOT and AND gate. So when there's a output of a true value from the timer block, which is when there is still like chemicals needed to be pumped from pump A, and pump A itself has failed, which is given a false value. We use an AND logic gate to activate the backup pump A, which is needed. And this is the same implementation as used at pump B. And from here, we use a negative edge contact block, which allows us to see when the timer block has like ended, like ran out of the 10 seconds, and yes, changed from a Boolean value of 1 to 0. And this would kickstart the timer process of like activating our mixer component, which is seen here. And this is the rough logic that we use for the rest of the circuit. And we implemented to stop the the machine at any time, we implemented a S1, S2, and stop, like a normally closed contact switch in all of our mixers, pumps, and backup pumps to stop the mechanism at any point in time. Then to repeat the program, we decided to use also a negative edge contact block to like so basically when the mixer itself the final mix has been done, then the program would send another Boolean value, like a true value, to the counter, which kickstarts the entire mechanism again. And this is just a breakdown of each like individual component of our planning, which I just went through. And so this is how our rough idea of how our LD diagrams will look like. And from here you can see this our start PB and a positive edge block, and this is our counter block, the CTU block we have used with a reset PV component here. And this will be connected to the first timer block. And this timer block is then connected to the pump A, which is how we implemented the pumps in. And this is our implementation of the backup pump, which is using NOT and AND gates.
Sorry to interrupt, team, but your time is up.
Our time is up. Okay. Can I have some? Can I say some stuff before I end off? A short few lines. Anyway, we felt that this was a really difficult project, and we felt that given more time, we could complete our project. But we are really not really familiar with the program at this point in time, and we will seek to complete this project in a future point in time. Thank you.
Thank you. We may now move on to the questions. Judges, if you have any questions.
Actually, I would like to hear what he say on the second part on his logic. Things he can continue to explain that.
So on the second part of logic, actually we basically use like the same thought process as what is used in our first part, which is what I explained in our rough idea of our diagrams earlier. And this is basically a negative edge contact block that we thought about, and then this is the stoppers, the stop buttons or the switches to like in case the tank is full. And then this is basically the same implementation as pump A, and actually this is just our simple implementation of like activating the tank drainer, like in case the switches or the tank was full. Then unfortunately our program was like unable to run because we realized that we made a mistake in the usage of these negative edge contact blocks, as they do not seem to take in like
Can you take out the negative edge and run it?
Negative edge. Actually our project quite a lot of errors. Then
okay.
I can negative edge. We tried building it, but we actually ran out of time at that point in time, and it was sorry, it's taking a while. I'm not sure if it's working actually. We couldn't fix some of the transfer issue and stuff. So it actually can't run.
Yep. Okay for me.
Yeah, so it gets stuck here for some reason. We couldn't fix the problem for quite a while. So we ran out of time. Yeah. Yeah, so we did manage to get a HMI implementation or which yeah. It's not very familiar program. so, do you have any more questions for us?
Just a general comment to all the teams. We can see your hard work that you have put it in, but if it doesn't work or it doesn't simulate anything, then all your effort is wasted. So even if it is 50%, just leave it there and just try to show us what you have done. That's more important than completing your entire task and leaving it not working. Yeah.
Yes, understood.
Yeah, maybe just to add on a little bit, maybe you can share your lesson learned during this competition, like what this team doing right now.
Because your theory level of explanation is very good, but we would like to see it on the screen as a workable solution. So if theory wise is okay, but yeah, when it comes to operational, then this is not sufficient. At least you should show us some simulation part of it.
Yeah, understood.
Yeah. Thanks.
Thank you.
Good work. Yeah.
Thank you for that time. Thanks.
Thank you.
Thank you. Next we have Team Horizon from APU. Team Horizon.
Hello. Please give me a second so I can share my screen.
Okay.
Okay, is my screen working?
Yes, we can.
All right, so without further ado, I will just start my presentation. A very good afternoon to everybody, to the judges as well. We are from Asia Pacific University, Team Horizon. So my team consists of Wong Chi Kei, myself, Sua Jing Yi, and Wong Chi Sing. Okay, so moving on, this is our general understanding, a very rough diagram based on what the questions were given. So the start PB starts, and then we go into the pump A. After 10 seconds, the mixer M1 will begin. And for 5 seconds later, the pump B will start. And for 8 seconds, it will go back into the mixer M1. Next, it will move on to check for the counter and the S1 and S2, whether it is full or not. They will give an indication. And if it is full, then they will check for the overflow, and then we will drain the valve. Okay, so and of course this process will repeat, and then by clicking the start BP again. Of course, this is just a rough diagram. Actually, there's a more in-depth diagram that were drawn by us. The logics behind, and before we jump into the automation studio, there's actually a lot of logics that we have thought about on how the ladder diagram should be, what the flow of the system. But we are unable to retrieve the file because we have deleted it. So that's a very unfortunate. So before I jump into the introduction onto the ladder diagram of the Automation Studio, I would like to confess that we were unable to complete what the questions require us to do, and we are also unable to reach the HMI level. So we are just only able to complete part of the ladder diagram. Okay, so jumping to the system. This is the system activation. We actually, before the start PB, we have a system start so that the system can run, can provide power to all the ladder first before we start the system. Okay, so this is really nothing much important. It's just to prevent bugs and any error going. Okay, so moving on, this is the pump A. So when the start PB is pressed, pump air will begin its work for 10 seconds. And after the 10 seconds, the reset pump air will activate and it will stop the pump air from continuing. And then we'll move on to the mixer. The mixer will start for 5 seconds. And after 5 seconds, the mixer will also stop by having the reset mixer M1 cut off. Then pump B will also activate later on. Do not worry, as it may look confusing for now, but we'll have a video later to show how the flow will be going. Okay, so this is roughly on how it will be working. Of course, we have more than one method to stop it because we don't want the pump air to repeat non-stop after the pump B is completed and the mixer M1 is completed for the second time. Because we found out there's a bug where it will keep repeating. So we try to figure out, we put in a lot of time to try to figure out how to stop it from happening. Thus, we have this loop control. We call it loop control. But so the stop M1 step 1 will start after pump B stops. So pump A begin and then mixer begin for first time, and then pump B will start. So after pump B started, we will stop this. We will have this loop control to prevent the ladder diagram of the first mixer step 1, the first time the mixer M1 is starting. So otherwise, it will repeat pump B and then M1 and then pump B and then M1. So this is the problem that we found out. Thus, we add another diagram to control this. Okay, this is the second time where the mixer M1 will begin after pump B is initiated and it's completed its work. So mixer M1 will activate again for 5 seconds. Okay, and then after it's completed, we added a counter here because we are not sure how we need to indicate that the fuel tank is full. So we decide to just make an assumption where after 2 revolutions, the fuel tank will be full and the indicator will light up. This is just an assumption that we made, and it may be very wrong. However, we were running out of time, and this is what we have figured out. Okay, so this is some of the stuff that we managed to complete in the 3 hours time. I know it is not a lot, but we did pour in our heart and effort to try to figure out everything we could. So we were able to activate the pump for 10 seconds and then activate the mixer the first time, and then pump B for 8 seconds, and then the mixer M1 the second time. And then we're also able to make the S1 counter increase by 1. And once it reached the counter reach 2, the indicator will light up. And this is what we are able to achieve, and that's all. If we were able to, so this is a sample simulation. Before I jump into here, I would like to talk about some of the things that we could improve on. So we missed out the backup pumps, that's for sure. And we also actually used 2 LD ladder to activate mixer M1, which we think that with the proper logics implementation, we could make it into just 1 ladder diagram and it will be more efficient that way. So obviously, HMI is going to be a better user experience if we are able to complete it. We are not able to complete it, not really due to the time constraint, but just because we are lacking the familiarity in the app, which is Automation Studio. So we are not really familiar with this with the application, and we were not able to understand fully on the logics of how the ladder diagram works and all the components in there. I'm pretty sure there are a lot of components that we do not know about, which can make this job easier and could be done in a very in the time limit. But just because our lack of knowledge, we were not able to complete it. So since I have time, I'll just play the very short to talk about our program. Okay, so the watch, and then we have the system activate. So once the system activated, I'll let you pause here. The diagram, the pump air have not started yet. It's just to make sure all the power are flowing in the ladder. And then next we'll start the PBU. So PBU1 started, and you can see pump air is actually running, and the timer is also counting down already. So this is a bit lengthy because it's 10 seconds. So after 10 seconds, oops, I'm so sorry. So after 10 seconds, you can see that the mixer M1 actually start mixing the pump, the fuel tank. So this will run for like about 5 seconds. Okay, now you can see after the mixer is completed, pump B will initiate. Pump B will go for 8 seconds. Okay, so you can see in ladder diagram number 5, we actually have stop M1 step 1. This is to stop the previous mixer M1 ladder from initiating again. Otherwise, once if it is initiated, pump B will resume and thus the loop will begin. So we want to control the loop from happening. That's why we added this ladder diagram 5. It's a cheap method and I think it's inefficient. So we could actually further improve on that in my opinion. And so finally, M1 will run for another 5 seconds and it stopped. Then as you can see, the counter increased by 1. So running again, if you run the simulation one more time, the counter will become 2 and the indicator will light up. Okay, so that's all from my group Team Horizon. Thank you very much. Thank you very much for letting us join this competition and listening to our presentation. Though it is incomplete and not perfect. We hope to do better, of course, and we will improve ourselves furthermore on this PLC in this automation studio because we actually find it very interesting and very fun to play with. So yeah, thank you very much. Moving on to Q&A.
Yeah, now, judges, if you have any questions for the team, you may ask them now.
I think this team did, sorry. I think this team did a very good job. Slight. I think you all miss out on the limit switch, but overall, I think the system delivered very well.
Thank you very much.
Yeah, it's a good try for the mixer part. When you instead of doing these logics, you can take the output of the two mixture ladders, and then you can parallel it and activate the final output, because anyway you will have only one connections to the digital output to turn on this mixer. In that way, you could. Yeah, the program is very simple and easy to understand. Yeah, good work. Keep it up.
Okay, thank you. Yeah. We will try our best to improve on the diagram.
Any other comments or questions or feedback from the judges? If no, then we move on to the next team. Thank you, Team Horizon.
Okay, thank you.
All right, next up we'll have team of 5 from RP to present their simulation work. Team of 5, are you here?
Sorry. Yeah. Yeah, team of 5. This is our presentation.
Yes.
Uh,
All right, you may start.
This is our simulation. And so we have some errors for our simulation. You say this is on top mid one.
Okay, yeah, but essentially, right, we didn't manage to add in the one part as we are lack of time. So like yeah, but we wanted to, cause we want the pump A to run for 10 seconds before it stops and the mixer M1 starts. So with this timer, right, I would want to latch it to this part with normally close. So after this timer, right, you will cut this latch and pump A would stop. So likewise to the other mixers. So so it repeats the same pattern using using a timer to cut off the
circuit.
the circuit. Yeah. Yeah. So that's about it from us.
Yeah, and this is our first time doing doing this simulation, so we might not be as good as compared to the rest of the teams that has presented before us.
Yeah.
Hopefully, we have more skill and knowledge, right? This will be better, and we are be able to troubleshoot our errors better. So thank you. Judges, any questions?
Judges, do you have any questions you'd like to ask this team?
Can you rerun the simulation again, just one more time?
Okay, sure. You can run again. I think we force it, isn't it? Yeah, that's about it from us. Yeah.
Okay, sure, thanks. No questions from my end.
Stop sharing.
All right. Thank you, team. Thank you, team of five from RP for your presentation. Next up, we'll have Team Citizen from SIT to present. Team Citizen.
Hello, are you able to hear us?
Yes, we can hear you. Hello.
Okay, give us a moment, we share the screen and
Right.
Then the PowerPoint slides.
yeah, over there. You want to share?
Present. All right. Okay, we are from SIT Citizens.
Camera here.
So I'm Enyu. This is Lemon, and that's Pei Xian, all from SIT. Yeah. I firstly would like to really thank the organizers at RP. Without them, they really came in clutch for us and provide us a laptop to do this. Otherwise, we won't have been able to do the software at all. Okay, so we looked at the problem statement and we broke it down into its key components. So what we did was to turn it into an SFC, which Lemon will.
Yeah, okay. So in the SSC itself, what based on the problem statement, we have a few criteria of a flow in itself. So SFC itself shows a very nice flow. So you can see at point number 0 all the way at the start. Okay. So we are waiting for the start button to be triggered. After that, the pump A and then the amount of time mix again, pump B, amount of time, mix again. And then at the end of at number 5, sorry. Yeah, so we then check for the switches, the limit switches, whether have they been triggered. So if they have not been triggered, then we goes back to the pump A again to start at point 1. So once it's being triggered all the way to point 6, then we turn on the valve. And we'll turn on the valve until the pump, until the switch has turned back off. Okay, so this is our whole criteria for the whole ladder programming. So next part is that we actually convert the whole thing into ladder itself. So you can see that this is our whole ladder programming. Okay, so let me just go side by side and you get a nicer view. Okay, sorry. Yeah, so you can see that pump A again at point, oops, sorry. So at point number 1, and then you can see that it's waiting for the push button, then it goes to R. So I use R in terms of the 0, 1, 2, and 3, all the way under 7. Okay, so this all the way down, and then R2 itself. So it's a bit small, and yeah. So R2 itself, then it turns on the part. The R2 turns on the mixer. Yeah, turns on the mixer, and then the time again. So this is how we do the whole programming. All right. So the next part is we'll showcase our solution on our HMI to interface everything.
Okay, sorry. Show the team viewer. Sorry. So our HMI, initially we had some issues with the HMI.
Yeah.
This one, yeah. So initially we had issue with the HMI where we used push buttons, but the push buttons were latching instead of triggering, and then that kind of messed up our whole ladder diagram. So actually we did, after lunch, we did change it into momentary switches. Yeah, so right now you will see that the cycle will start, and now that water level has went past the limit switch on the left, the S1 is being triggered. However, you still continue through the cycle until end of cycle, then you turn on the drain valves to get these proper mixing ratios.
Yeah.
So
yeah,
as PB is finishing and then the last mixer cycle turns on, you see the drain valve at the bottom will turn on and you drain back down to below the limit switch value. And then the cycle should end.
It will stop. Give it a bit of time. The drain is a bit small.
Yeah.
Okay. Yeah. So you have the start counter at the top also, and so for pump A and pump B, this is more for future work. We wanted to have like a recipe so that you can change the amount of amount of pump cycles that you want. So in terms of seconds. Yeah. So then it's not complete, but it's just showing you that this is something that we want to add on in the future. Yeah.
I think that's the end.
And that would be the end of our solution. And one more point is that we didn't do the backup pump also. Yeah, and should we show the before?
Oh yeah,
So this is the one we submitted.
Yeah, this was the version that we submitted because we did a bit of we changed a bit of the buttons after lunch. So there was a bit of a problem for this one.
Yeah, so this what actually happened was you just keep looping through because the HMI was push buttons instead of momentary buttons, because the push buttons were latching in the software for some reason we couldn't figure out.
Yeah. So that was the problem that we faced, and that will be it for us. Do you all have any questions for us?
Judges, do you have any questions for Team Citizen?
Is it possible to look at the simulation again from the start? Then you reset the water level.
Sure. So once you reset the water level, I reset the timer, the counter also. The start counter. So once we start, then it would slowly fills up. It will take a bit of a time for the water to go up. Yeah, I think we planned around 3 cycles.
Yeah,
we planned 3 cycles.
So this was just an arbitrary value just to simulate how it will go through.
So the limit switches will turn color when it touches?
Yeah. So right now S1 is the only one that we are using for the water based on this programming, and S2 is just there in case that you want to manually override it.
Okay.
So only S1 is hard triggered from the software. Where once the water touches S1. S2 will not turn on until it is meant for like a backup sensor or something like that.
Trigger? Yeah, okay,
so
finally.
it triggers. So it still completes the cycle until the pump B finish and mix.
Is there any counter for your button?
The start button over here?
Yes.
So right now the process has stopped because we have completed the whole cycle. So if we press start again, the counter would change value to 2.
Okay. So the missing part is only the backup pump,
Yeah,
right?
backup pump.
Okay. I think great effort. Thanks.
Thank you. Thank you. We have any more stuff, or we can.
Judges, do you have any more questions for Team Citizen? All right, I think that's it. Thank you, Team Citizen.
Okay, thank you.
All right, is there any team that we have missed or waiting? I don't believe so. If not, then that's it for all the teams today. We'll now have a 20-minute breaks. Please come back to the room at 5:10 p.m.
Sorry, it's at 4:40. 4:40
4:40.
p.m. Yes. So come back to this room at 4:40 p.m. Thank you. Welcome back, judges and participants. Before we announce the winner and runner-up of this competition, let's request our judges to comment in general on the performance of all teams. Judges, please.
So maybe I can speak. First of all, I would like to thank all of you to invite me to judge for this event, and it was very interesting to know. And means the students trying out, especially when they don't have any experience on PLC programming. At the same time, we saw the teams with the different kind of, you can say, skills and the trial methods, their presentation skills. But if I see as a overall, I think it's a very good, what do you say, showcase by the students. Of course, in an event, everyone, some are winners, will be declared winners, I will say. But at the same time, it's a learning experience for everyone. So if you are not there, so learn out of it and see how you can better yourself. So good luck to all of you for your future endeavors.
Thank you, Mr. Vinny. Mr. Stephen Teo, is there anything you would like to add?
Yeah, thanks. Yeah, I think this is the second year that I participate in this judging. I really appreciate you guys to invite me. So every time when I'm being to judge this competition, I felt that everyone is the winner lah. So you all basically will take away experiences from this type of competition. As mentioned just now, this is a platform whereby you can make mistakes and there's nothing happen. Because in real life, basically cost is an issue, timeline is an issue. So as most of you have mentioned, you all did this learn this program within a very short period of time, which is really not easy. It's not an easy feat for you to get familiarized and understand where are the functions. Basically, you have the logics in your mind, but you have difficulty to actually come up with the actual program. Actually, this is very normal, which we experience every time as an engineer in the field, because you have a lot of different brands as mentioned by the different judges like Omron, Mitsubishi. So it happens when your boss tells you to do a certain programming using a different brand of PLC. You have to work your way out to get it done. But as per se, this is a growing experience. You gain knowledge. The concept, most important here, I think we want you guys to understand the framework of how you think the logics. I really can see most of you before you all start, you know how the flow of how things is being processed, how is the system going to be operated. That's very important. So I thanks everyone, the organizing committee, and also all the students that participate in this competition. As per the last judge saying that there will always be a winner, but don't be disappointed that you don't win this competition. There's a long way forward. So yeah, thank you very much. Have a great day. Thanks.
Any? Thank you, Mr. Steven. Dr. Fernandez or Dr. Lee Jian Yuan, do you want to add anything on to the comment?
Yeah, sure. So maybe I just say a few words. So first of all, thanks the RP for organizing this wonderful event, and I believe all the team have done a very good job, and each participant is a winner already. I think everyone have learned something either during the competition, how to analyze the problem statement, and also how to start a very new, I call it a short project within 3 hours. That's very impressive. And each team have done a very good presentation as well as the deliverable. So I would like to encourage all the students here, either from poly or university in Singapore or overseas, to continue learning. So maybe I share some insight. Even for adult learner like an engineer, to learn all this, it took some time to learn the knowledge, skills, concept, and practice on their job at the end to fully implement into a real project in the industry. It takes maybe a few years. So I like to encourage everyone to continue learning even after you graduated from your current diploma or degree study. Yeah, thank you.
Thank you for the comments. We would also like to thank all the teams for joining us this whole day for the Southeast Asia Region PLC Competition 2022. Without further ado, we would like to begin the announcement of winners, starting with the second place. In the second place, we have Team Horizon with their unique simulation to solve today's problem. They have surprised the judges with 54 points. Any words from the team?
It was a very unexpected result because we actually did not expect ourselves to win with such impractical LD diagram. Is inefficient in some way, and we are unable to fulfill the requirement at the same time. However, we are glad that we are able to achieve the run-up for this competition. And of course, we will also hope to overcome the challenges that we have met in this the question. Though the competition may have ended, but we still seek and hope to improve ourselves in designing in this PLC diagram, because out of not trying to win any more competitions or anything, but just the desire to improve ourselves and gain more knowledge in this field. It is very interesting. Never expected it to be such a fun event, though it is a competition. It is very enjoyable and fun at the same time. Thank you very much.
Thank you, Team Horizon. Finally, this is the moment we have been waiting for. The winner of the Southeast Asia PLC competition is Team Citizens. Congratulations, Team Citizens. May I request the leader of the team to say a few words?
I heard you. Yeah. You can
They got a camera. There is
yeah, they.
Hello. I guess we really have to thank the RP organizers a lot. Because I realized that actually a lot of people have issues with the software. It's only because of the organizers providing us a laptop here that we are able to actually do the program to its completion. We had a lot of fun today doing this program, I think, and doing the learning everything was pretty exciting as well. I would say within the last within 2 hours, I guess. Anything from I guess.
We had fun.
Yeah,
We had fun. We had fun.
Yeah. Right, thanks everybody for this opportunity for this event.
Congratulations to all the teams. Well done. We will contact both the winning teams at the end of this event. To the other teams, we hope you have enjoyed learning PLC from this event and continue to explore more on PLC programming. We will now move on to the last segment.
We would like to thank all the judges and guests of honor for making this event successful.
We would also like to thank our ALOs of each student chapter for giving us the opportunity to organize and participate in this event. And last but not least, we would like to say a big thank you to all the participants and organizers from IMECI student chapter of Republic Polytechnic Singapore and Asia Pacific University Malaysia. Before we end, let's take one last commemorative photo before we go. Please turn on your camera and we'll take one last photo. 2, 1. All right. Thank you all. I have been Aman, the president of the IMECI student chapter, APU Malaysia.
I'm Afif, president of IMECI student chapter, Republic Polytechnic, Singapore.
I'm Hui Xuan, Director of Welfare, IMECI Student Chapter, Republic Polytechnic, Singapore.
I'm Adil, HOD of Technical and Logistics, APU IMECI Students Chapter, Malaysia.
And thank you all for attending and enjoy your weekends. Bye.
Thank you guys.
Bye.
Bye-bye. Take care.
Thank you guys. Bye-bye.